In 6.2, we're looking at triangles. So let's first look at problem 1a. In triangle ABC, suppose that measure of angle B is 46 degrees and C is 67 degrees. Find the measure of angle A. So I'm just going to draw, this is not to scale, a triangle with A, B, and C. So measure of B is 46 degrees. Measure of angle C is 67 degrees. We want to find the measure of angle A. We know that three angles will all in a triangle will add to be 180 degrees. So the measure of angle A plus 46 degrees plus 67 will add up to be 180. Let's solve that equation. So the measure of angle A plus 113 is 180. We're going to solve for the measure of angle A, and we could have put an x there, a variable, but I'm going to keep that there. So let's subtract 113 from each side. So we've got the measure of angle A is equal to 67 degrees. Okay, move on to the next problem. Find the measure of angles 1 through 5. Okay, so let's use what we know about, first of all, the three angles of a triangle. It looks like we could start in this triangle where we know that this is 90 degrees. So we have a 90 plus 40 plus the measure of that first angle would add up to be 180. So 130 plus the measure of that angle equals 180. Subtract 130 from both sides, and that would give you the measure of angle 1 is equal to 50 degrees. So I'm going to pencil that in. If we know that the measure of angle 1 is 50, 1 and 3 are vertical angles, so they would have the same measure. So angle 3, let's draw this in. So we've got the measure of angle 1 is 50. Measure of angle 2 we'll find in a second. Measure of angle 3 we said was 50. Now we could look at supplementary angles and see that measure of angle 2 and 3 form this straight line. So 2 and 3 would have to add up to be 180, which means that the measure of angle 2 would have to be 130 degrees. Also look at angle 4. 2 and 4 are vertical angles, so it would have the same measure as angle 2. Okay, so measure of angle 2 was 130. Measure of angle 4 is 130. Now we just need to find the measure of angle 5, which would be the third angle of this triangle, which we have 80 plus 50 plus the measure of angle 5 add up to give me 180. So 130 plus the measure of angle 5 is 180. Subtract 130 from both sides, and we'd see that the measure of angle 5 is 50 degrees. We're going to omit 2a as well as 2b and move on to 3a. Using the Pythagorean theorem. Now Pythagorean theorem says that a squared plus b squared equals c squared, where we've got the leg squared plus another leg squared is the hypotenuse squared. Find the length of the hypotenuse in a right triangle whose legs have lengths of 8 meters and 15 meters. Okay, so those would be our A and B. 8 squared plus 15 squared equals the hypotenuse squared. So 64 plus 225 is C squared. That would make that 289 is C squared. Then to find what C is, I'm going to use something called the square root property, where if I take the square root of each side, the square root of 289, which that button can be found on your calculator if you type either the square root key in 289, or depending on your calculator you might have to do 289 in the square root. but that's 17, since 17 times 17 is 289. And then the square root of c squared is just c. A square root function will basically undo a power of 2. So we know that c times itself is c squared. Okay, so we found the length of the hypotenuse would be 17 meters. Okay. And then next we've got a baseball diamond. It says it's actually a square with 90-foot sides. So let's draw a baseball diamond. Each side is 90 feet. What is the distance from home plate? So make this our home plate. To second base. Home plate to second base would be this length. So we basically have two right triangles, since we said that this was a square. All four of these angles were right angles. So if I have a Pythagorean theorem on one of the triangles, those would, let's draw it over here. So we've got the 90, 90, and we're trying to find again the hypotenuse. So 90 squared plus 90 squared is x squared, or the hypotenuse squared. 8100 plus 8100 is x squared. 16,200 would be x squared. We'll do the same thing we did in the previous problem. To find what the hypotenuse is, take the square root of both sides, which gives me 127.3 feet would be the hypotenuse, and that would be the length of between home plate and second base.